Hey guys, welcome back. Today we're going to be looking at how to find the distance between a point and a plane. I've got a little visual for you here. You can see this is the plane in grey. It's not our exact question, but similar. We're going to be joining up the point to the plane along its normal. That's really important in order to find the shortest distance. So we're going to take a point here. We're going to form a line that moves along the normal to the plane, and we're going to find the point of intersection of the plane and the line. We actually need the whole point of intersection, although you could find it and then find the distance between these 2 points. There's a slightly faster method. What you're going to do is just find the lambda only of the point of intersection, and then you're going to measure this vector that takes you from here to here. Okay, cool. So let's have a look at our example. First things first is we need to know what the normal to the plane is. To find the normal to the plane, we need to look at the coefficients. So the normal to this plane is going to be n is equal to 3 minus 1 plus 1. Okay, so this is our plane. Okay, we got our point up here. 1, 2, 0. And then we're going to form a line that takes us down to our plane along the perpendicular. So the equation of that line is going to be, using the point that we've been given, 1, 2, 0, and lambda, and our direction vector being the normal, so that we're going in the shortest direction. That is going to be the equation of the line. Now, we know from previous videos that the best way, or the simplest way, to find the point of intersection of a line and a plane is to have your parametric equations and sub them into your plane. Okay, so I found the equation of my normal. I used that as my direction vector. I found out what a general point on the line would be. Okay, and I'm going to find out which value of lambda will allow me to intersect here with my plane by subbing in these equations into my plane. So I'm going to have 3, instead of x, I'm going to have 1 plus 3 lambda minus 2 minus lambda plus z equals lambda equals to 5. That's 3 plus 9 lambda minus 2 plus lambda plus another lambda equals to 5. The reason why this method is really easy is that you end up with one equation, one linear equation in terms of lambda. So you've got 9 lambda, so that's going to be 11 lambda, plus 3 minus 2, that's going to be 1, plus 1 is equal to 5. So if I solve for lambda, I've got 11 lambda is equal to 4, and lambda should equal to 4 over 11. Now, at that point, you could actually substitute in your value for lambda here, and you would actually have the point of intersection. You could then use the distance between 2 points formula, and that would work out perfectly fine. What I'm personally going to do is I know that this vector here is equal to lambda times by 3 minus 1, 1. So instead of subbing in lambda is equal to 4 into the line equation, like I said, to find the point and then finding the distance between the points, I'm going to use a slightly faster method. That is to straight away sub in 4 over 11 here, and then just simply measure the length of that vector there. So that's going to give me 12 over 11 minus 4 over 11 and 4 over 11. And then I'm going to find the magnitude of that vector, which is going to be square root of 12 over 11 squared plus minus 4 over 11 squared plus 4 over 11 squared. And that is going to be the shortest distance to the plane. Cool. I hope you love this video. I really love making these videos for you guys. Subscribe, that makes me so happy. And I'm going to be looking at how to find the reflection of a point in a plane directly after this video. Bye for now.